Now we come on to a different set of details. That's on the use of FutureGrid for testing Exceed. And Exceed has many there's various capabilities that need to be supported. One is the Technology Investigation Service, sometimes called TIS, which is a part of Exceed that basically investigating technologies which are not yet not yet deployed on Exceed, but to see if they should be employed on Exceed. So using FutureGrid to do that investigation, or partly to do that investigation, is an attractive thing to do. Another part of Exceed is the actual software development and integration, which is to actually do the necessary software engineering to produce high-quality software for the Exceed resource providers and the actual users of the Exceed systems. And if we go to campus bridging, where we take the Exceed software and run it on campuses, that will also benefit campuses across the nation. And here we have the Exceed STD, which is the software testing and development, which is doing acceptance testing of new Exceed capabilities, a new file transfer service, or a new distributed file system, and things like that. So GFFS is a file system, distributed federated file system. And so here's an example of using multiple FutureGrid systems. Here's one reason why FutureGrid is distributed. If FutureGrid is going to test Exceed software and Exceed is distributed, then it's presumably important to make the test bed also distributed. And so here we see the use of X-Ray, India, Sierra there at India, the first two at Indiana, Sierra's at San Diego, and they were used to test the this federated file system, GFFS. Here's another example which used Nimbus on hotel, connecting to different sites around the nation, and they were emulating different Exceed systems, and was used to test the XD usage software package, which is a way of looking at allocation information at Exceed. Now we discuss how FutureGrid fits on a national and international perspective with different activities. The first slide here is some of the features of FutureGrid, which are particularly novel. And this slide actually was also in the overview, but I'll go through it as I have it here, and it makes the discussion here more self-contained. We wanted to emphasize that there is an important difference between Amazon, Azure, and Google Compute Engine and FutureGrid, and that the commercial systems are aimed at production. They're not aimed at reproducibility. They give you answers, not reproducible answers. The FutureGrid aims to do robust, reproducible experimentation in support of research. And so it means you can request a node, and you can get it with and without virtual machines. And so it's a very open, transparent technology environment, whereas if you read papers which have used Amazon, the results can be really interesting, but it is relatively difficult to actually know what the people have measured, because a lot of some, especially, and also the same is true on the other commercial clouds, because the commercial cloud vendors doesn't tell you what it gives you, and also some of the aspects of those clouds are proprietary. Another difference between FutureGrid and those commercial clouds, it's actually a general distributed sandbox. It supports clouds and grids and HPC. We also have multiple infrastructure as a service environments, Nimbus, Eucalyptus, and OpenStack supported, and another two, CloudStack and OpenNebula, available through projects. We support not just production, but research on new tools, new middleware, and also through the distributed environment, distributed and federated systems. I pointed out that the FutureGrid has developed testbed as a service tools and middleware, which allows it to actually operate and deliver on its mission. Examples from the Nimbus group is Phantom, the cloud user interface, and Nimbus itself is a very nice example. Vine is the virtual network software, which will turn up on the later slide. Rain is the dynamic deployment and provisioning system from Indiana University. And we've also integrated and had to integrate a lot of security and metric features so we can report FutureGrid use in the same fashion as other Exceed systems, and also allow the security model for users, which is independent of the fluctuating and different security environments offered by the different IaaS environments. And of course, we have a lot of experience in running cloud systems. So this is another slide from the overview. This is, and we'll have some more slides which will basically go through this in more detail. So I will actually now go through the following slides and tell you about Grid 5000, Open Cirrus, Planet Lab, the various Genie projects, Bonfire, EGI, and in detail. So EGI Federated Cloud is actually about the same size as FutureGrid. It uses either OpenStack or OpenNebula, and it is built on the European Grid Initiative, EGI, and is basically offering a cloud environment built on the federated grid environment between the different nations in Europe. Grid 5000 is quite near FutureGrid. It is centered in France, but has some sites outside France, and it is dominantly supporting computer science in the same experimental model that FutureGrid has. And we learned an awful lot from Grid 5000 in proposing and running FutureGrid. Obviously, they do things we don't do, and we do things they don't do. And we've had more of an emphasis on actual platform as a service frameworks and the different infrastructure as a service frameworks than Grid 5000. EmuLab is a very important testbed, mainly for the network community, and it's been integrated into Genie and deployed in a number of sites. And they have a pretty interesting set of tools we should try to make better use of as we try to improve our linkage with the network community. EmuLab is still expanding, I think, and is a very active project which FutureGrid will try to work with in the future. Probe is an EmuLab environment, a recent one. It consists of recycled servers from Los Alamos National Lab, and it will then, with the comments there are similar to EmuLab, we need to work more with these people. Planet Lab is a very famous system consisting of hundreds of machines spread across the world. It supports wide area, rather informal distributed systems research because they're very unmanaged and uncontrollable, but it's probably the best known of all these environments. ExoGenie links Genie to OpenStack and federates independent cloud sites and circuit providers through the infrastructure as a service interfaces. It has an interesting piece of software called Orca as the controlled environment, and we hope to work in detail with ExoGenie, as I'll describe later on. ProtoGenie is part of the EmuLab Genie integration activities. Genie, of course, is a highly active, large set of network experiments with multiple projects. And as I stressed, the network as a service should be an important part of any computing testbed as a service. Genie and FutureGrid need to be actively linked.